Okay, so let's now close the design modeler and let's now take a look at the fluid mesh. First, we again see our fluid geometry. If we expand geometry, we see that it is this body. Also notice that the actual blade geometry is represented by these surface bodies, but the blade geometry is suppressed for now, shown by this X, because it will be used later for the structural section of the FSI simulation. Also notice that important surfaces of the fluid geometry have been given names. These are used to define some of the mesh settings and are needed for the upcoming analysis in Fluent. Let's now take a look at the mesh. Here you see that the mesh is mainly composed of tetrahedral elements and that the mesh has been refined around the blade in order to obtain more accurate results in this region. Let's now make a cut through this mesh to visualize the inside, especially around the blade region. So first, let's rotate this mesh slightly, and then we'll click on the New Section Plane button. And here you can see a few settings that pops up. So we'll make a cut right here. And then if we use this button, then we can first click on this line to show the other side if we want. And we can then move through the mesh by sliding using this button. We can take a closer look here. So this method is good, but we can do much better. I have a little trick. So first, let's delete the section plane that we just created. And then we'll move on to the visualizing the geometry. Then click on the X-axis and zoom in slightly on the blade. And then use section plane again so that it goes through part of the small airfoil and also the large airfoil, like this. We'll select this side, and now we can go back to the mesh and rotate it slightly. So now we can clearly see the wind turbine blade inside the mesh. To create this mesh, both global and local settings were implemented. The global mesh settings are located in this window, and it affects the whole mesh altogether. On the other hand, the local mesh settings are located here, and these settings affect particular regions of the mesh. So for this mesh, we use something called match control, which was implemented on these two surfaces, such that they share the same nodes on this line. We also set a particular phase sizing for the cells around the blade. And then we use something called inflation layers, which if we zoom in a little more, we can see these wedge elements. So this is done using inflation. And finally, we have something called body sizing, which is something called a sphere of influence, and we can refine the mesh in this particular region. So this was it for the brief introduction of the geometry and mesh of the fluid region. If you want to learn on your own time how to create the geometry and mesh yourself by following much more detailed explanations, then feel free to look at the startup, geometry, and mesh sections of the wind turbine blade FSI Part 1 tutorial on simcafe.org.